I'm sorry, it's pi over 1/2. I'm already messing up, which is 2 pi. So that means the width between the vertical asymptotes is now 2 pi. So it's pi left. And it's like, again, kind of comes down like, how do you want to like organize this now? This can now be minus pi. This is now positive pi. All right. And then it has this snake shape again. So you generally put a point right in the middle for the parent function. And then this is now at pi over 2 and minus pi over 2. You just split kind of the midpoint between the vertical here and the vertical asymptote. And then you get one down here. It's going to have this kind of this snake-like shape, something like that. And then if you had to go out another period, which is quite common, this would now be at 2 pi. So this is now at, between the two of them, that's at, 3 pi. So that's now at 3 pi. And then you go over 1, up 1, like that. Let's make this. That's where it's like, well, I don't know if you're going to have to label these other ones. You might.
Wait, would that be 2 pi or?
Yeah, 2 pi. And then it's 5 pi over 2. And then this one's 3 pi over 2. Make sure you add some arrows at the end. And that's really it. Like, that's really it for tangent. The other things that they can do, we're going to do next, is reflection and amplitude. Is that okay? If we do those next? All right, so let's do like 22. It does say 1 period in your instructions. I mean, I don't know. It's did we already do that? Let's change this to I shouldn't do this one because we just did one like that. Let me make one up here. Y equals tangent 4x, and I'll put a -2 in front. That'll be better. So the period is pi over 4, which means that the width between the two vertical asymptotes is pi over 4. And you just got to be like, if you have the pre-scaled axes, this is where it gets really annoying, because this is pi over 4, this width here, which means it's minus pi over 8 left and pi over 8 right. Is that okay?
Yeah.
All right. So now I still graph the parent function. I still put that point in the middle, point, like this. And then we just got to label them. So it's pi over 16 minus pi over 16, like that. But now we can deal with the 2 and the negatives. The 2 pulls the y values up. So I'm going to do that in red here. The 0 stays the same, but this one on the right goes up there, and this one on the left goes down here. So it looks something like that. And then
wait.
question. Oh, did I go
So that's
3?
just implementing the 2.
Sorry, I put them in the wrong spot. There's so much going on here. Yeah, I'm sorry. It's in the wrong spot. It's just 2. Multiplication by 2. Yeah. It's now 2 and -2. But then we deal with the negative. So the negative will flip it.
Okay.
So now it's going to go, if it's down here, it's going to be up here. It's going to come down there. The 0 stays the same, and it looks like that.
Okay.
Is that okay?
Yeah.
It's a lot, right? And then there's even more that can happen. There's vertical shifts and then phase shifts and all that stuff, but we'll see. but I don't see much in the way of that in your homework. Um, but let me give me just like 30 seconds here. We'll do another one and then we'll switch to cotangent.
Okay.
And then if you wanted to go out another, I'll just make the comment here. If you wanted to go out like another period, which I don't really want to, you'd have to go out pi over 8 plus pi over 4, which would get you out to 3 pi over 8. And because this is so narrow, we're trying to squeeze all this in, but you would essentially, wow, I'm really not doing well today. All right, that's 3 pi over 8. You would just replicate this over here to the right.
Wouldn't we add? Oh wait, how did we get? Oh, because the period's on both sides. Sorry, never mind. That makes sense.
Yeah. Any questions on that? Or move on to the next one?
That makes sense.
All right. So now let's do a little shift here. Let's go y equals minus tangent 1/4 x. Let's make it even bigger. Let's go 1/8 x plus 2. What is the period?
8 pi.
Yeah, so pi over 8, or sorry, pi over 1/8, which is 8 pi. So now when we graph this thing, that's the width. So you got half that left and half right. It's kind of up to you if you want to like make this, you can make each of them 2 pi. I'm sorry, if that'd be 4 pi. You can scale it however you want, but the width here is the period. So then there's always the point in the middle, and then you split the difference here. So this is 2 pi, negative 2 pi, and then 1 and negative 1. I always like drawing the parent function first with the period change.
Okay.
All right. Then we have to flip it. So the flip comes next. We'll do that next. This negative one comes up here, the positive one goes down there. Like that. But then the plus two next, that means every point's moving up 2. That moves up 2, that moves up 2, and then that one down there moves up 2. So it still has the same sort of shape. It's just shifted up like that. Questions, thoughts on that before move to cotangent?
So if you move it up by 2, does that mean the dot on the y-axis is 2 and then
Yeah.
it's 3 and 1?
Yeah. Well, when you say 3 and 1, you mean, I'm not sure what you mean by that. 3 and 1.
Like
Like
for
like
negative 2 pi, the y-axis for that point is at
yeah,
3?
yes. Yes.
Okay.
And I'm not labeling any of these, which is bad. I mean, you probably need to label these, like you just said. Is this negative 2 pi, comma 3? This is 2 pi, comma 1. This is 0, comma 3. that okay?
Yeah.
Yeah. Please ask all your questions. This is not an easy topic. So cotangent of x, kind of like tangent, its period is pi over b. So when you graph it though, you start at the you start there and you go out the period like pi for the base case, and then there's pi over 2, and it's there, and then there's one left and then one right. So I got that dot in the bad spot there for the parent function here. So that's at pi over 4, that's at 3 pi over 4, and it does snake like this. We're going to build everything off of this one. Hopefully you saw that in class.
Wait, why wouldn't it be on the y-axis like tangent was?
Cotangent uh, is cosine x over sine x. Sine of 0 is 0, so it's undefined at 0. We're switching completely. You know, cotangent is
Okay.
related to tangent, but they're very different. Like they start and end in different places. They have different um, vertical asymptotes, behavior. You can make one into the other, but that's not usually what they're asking you to do at this point in the course. But you have to know this to start. You have to know this parent function to do any of the others. It's just way too hard to do.
Okay.
All right. So let me grab a problem from yours and see if I can find one. Let's just start with yeah, we'll just kind of do it the same way we're doing here. We'll do like 19 first. All right, so first thing is you determine the period. Period is pi over 3. What's nice about these is that it actually tells you how far out you're going. Not too far in that. You just know you're like, okay, I'm gonna go out pi over 3, wherever that is. Uh, so I'm gonna call that pi over 3, even though that may not feel like to scale. Then you've got to cut it in half. So that's pi over 6 there. And then this is where it gets like maybe challenging if you're not sure how to do this. You're just dividing in half and then you divide in half. Uh, or you find the average between pi over 6 and pi over 3. But you can also count. It's pi over 12 plus pi over 12 plus another pi over 12 ends up being pi over 4, I believe. There in the middle. All right. And then that point in the middle is graphed. And then you've got the parent function like that. So the period's the big thing. Now, if you had to go out another period, which could be the case, this width is the period. So we're going to go another pi over 3, which is 2 pi over 3. And really, I think the hardest part is just, did I even go out enough? I didn't. The hardest part, I think, is just going and like labeling these points because they're, you know, they're weird. But you have to know the increment. It's pi over 12 each time. So this is 4 pi over 12. So this next one would be 5 pi over 12. This is 6 pi over 12, but that's really pi over 2. 7 pi over 12, and then 8 pi over 12, which is 2 pi over 3. So figuring out this first one allows you to figure out what you're incrementing by each time. And then you do the same thing. You just graph the parent function ones.
How did you find out that it was pi over 4 for that section?
Sorry, it's just incrementing by pi over 12 each time. 1 pi over 12, a 2 pi over 12, a 3 pi over 12.
Oh,
That's
okay.
what each of these are. And then some of them simplify, like that one obviously simplifies to 3 pi over 12. Any any other questions before we do like a more difficult one here? Should be number 20.
No, I think I get it so far.
Okay. All right. So give me the period of this, please.
Pi over 2.
So it's pi over 1/2. What does that become?
Oh, 2 pi, sorry.
So whenever you see a fraction, that's the better case. It becomes 2 pi. That's nice. So you're going out 2 pi. Vertical asymptote, vertical asymptote. And then the middle one is pi, pi over 2. And so that's what I was talking about. It's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. These match the tick marks here. But some of them simplify, right? 2 pi over 2 is pi, 4 pi over 2 is 2 pi. They're just to help you label the ones that are weird. And so if we're to go out another period, right, 4 pi. The middle one's not too bad. It's the ones in between. It's like what's between 2 pi and 3 pi, maybe you already know, but 5 pi over 2 and then 7 pi over 2. It just could become kind of a kind of like that.
Okay.
Now the negative, what does it do? It's the same as all the other negatives, but what does it do here?
It flips the direction that it's facing.
Yeah, so if it was there, it's then there, and so on.
What's the difference? Okay, so when it comes to problems like this, there's no like distinct difference between cotangent and tangent.
I would disagree. Like from a pure math perspective, well, there's two ways to answer it. There is no difference between tangent and cotangent, but they go, to me, they go as like if I'm teaching you in the classroom, they go in different directions and they have way different vertical asymptotes. But like you could make the case that they start in one direction, go to the other. Um, there's ways to make them the same, and sometimes instructors ask that question.
Okay.
I don't know if that answers your question or not.
Yeah, no, that makes sense.
And you could say the same thing about sine and cosine. They're actually exactly the same. They're just phase shifted,
Mm-hmm.
but it's hard to remember all those little things. So that's why they teach them separately. All right. So I added in a cotangent or a vertical shift. You know, I don't know if we should do this, but you could get a cotangent phase shift. You could get like a x minus pi over 2. with other stuff. Has your instructor dealt with phase shifts on tangent and cotangent?
Period would be pi.
Well, I'm asking you, did your instructor give you anything like this? Because I don't want to cover it if you don't think you need
Yeah.
it. Okay. So, well, the first thing is you figure out the period. The period is still pi over b, pi over 1, because there's a 1 in front of the variable. The phase shift is pi over 2 right. Pi over 2 right. So
Hmm.
normally your graph starts at 0. The phase shift pushes your graph to the right. So instead of starting it at 0, you're going to go out to pi over 2. And then you have to add the period to that. So you have to add pi to it, which gets you to 3 pi over 2. I'm way off here on my drawing. Is that okay? You're adding the period to your phase shift.
Um, okay.
It's okay if it's not. Just, hey, don't understand. The first thing you do start with is the phase shift. It's pi over 2 right. Like normally it starts at 0. We're going to go pi over 2 right. But then you add the period to find the other side of it.
Hmm.
Okay. Then you graph the parent function. So there's that point in the middle. There's some point here and here. So this is at pi. So now we need the place between pi over 2 and pi. It's incrementing by pi over 4. So the pi over 2 is 2 pi over 4. So the next one is 3 pi over 4. That's this one here, 3 pi over 4. And then 4 pi over 4, that's the pi. Then the 5 pi over 4. So we're kind of jammed in here. And then you've got the one up and below. So that's the parent function.
Okay.
And the phase shift. Now we're going to deal with the 2. We've not dealt with the 2 yet. Like I've mentioned a bunch of times, it's always better to do that kind of stuff at the end. The 2 just stretches them up. So it's got a little, it's like, I don't even know what to say. It's a stretch, vertical stretch, like that. So this new point is 3 pi over 4 comma 2. And then this point right here is 5 pi over 4 comma negative 2. And then your instructor could add in, vertical shifts, plus a number over here, which would just add to sort of the complexity altogether. What do you think?
We do another problem like that, just to like,
Sure. Uh, want to do tangent? Is that okay?
yeah.
Or
And then
because
can we do like
cotangent's
another like tan problem like that?
well, cotangent's the easier one to shift, phase shift. That's why I chose it. It's easier to show this one first because it starts at 0. It's easier to phase shift from 0. If you recall, all the tangent ones were around this. So we have to phase shift each of these. And it's just awful, but we'll do it. It's just, it gets really, really, really messy. Um,
Yeah.
so I mean, that's just the way it's gonna be. All right, let's go. Y equals 2 tangent 1/4 x minus pi over 2 minus 1. All right, what is the period?
Or pi?
Yeah, pi over 1/4, which is 4 pi. Great. Phase shift.
Is it pi over 2 divided by 1 over 4?
No, it's pi over 2, right? When it's in this factored form, it's just this.
Oh,
So you're
okay.
you're you're thinking of when it's in this form. Uh, yeah, that's not right. Why am I struggling here? Pi over 8. When it's in this form, it is pi over 8 divided by 1/4. It's the b over c, which doesn't make any sense. Like, what do you mean? It's just weird. So I recommend factoring it out and then just reading the number. Is that okay
Yeah.
or not? Okay. So it's the normal graph, which if you remember, the normal graph here is minus pi over 2 to pi over 2. You phase shift to the right. So where does that put the new ones? It puts them here at 0 and pi. You always do the phase shift first, but the width between them has got to be 4 pi. So that means the width here ends up being 4 pi. So we have to kind of readjust our graph. This is going to end up being 4 pi there, but I won't do it that way because that'll be confusing. So it ends up being 0 to, and I'll just maybe just go out like this, do this, call this 4 pi like that. Tangent, you go to the middle, 3 pi, 1 pi, up 1, and then it's got this shape to it. Yeah. What's that look? That doesn't look right to me. Okay. Any questions on that part?
No.
Okay. That's the hardest part. Getting the knowing to push it out. It's the phase shifts first. You always do the phase shift and the period. Um, actually, let me check something here. I really just don't feel very good about what I just did. Um, sorry, I'm giving you. Did I graph this right? Let me do it without this number because I'm introducing too many things in here for one problem. Let me reset here. Y equals -2 tangent x minus pi over 2 plus 1. So this phase shift is important that we get first. So normally it starts here at minus pi over 2 and pi over 2. And these are a full period apart. Okay. The phase shift is pi over 2 right, which pushes both of these right. So it ends up being at 0 and then pi. Is that part okay? basically the same
The
problem, but just trying to reset it here. The phase
the
shift,
period
go ahead.
makes sense, yeah.
Well, forget about the period. I'm going to introduce that in a different problem because I did it in the wrong order and it didn't, it was, I knew it wasn't right. It didn't look right. So I'm going to do this just in the right order. Let's do the phase shift here first. When you move it to the right, you move it to the right. Okay. So our parent function now will look like, and that's between, and that's where I got too many lines here going, but it's between 0 and pi. Is that okay? How I came up with that?
Um, how you came up with
The phase shift moves the original one to the right, pi over 2 right. Like it's normally between minus pi over 2, pi over 2. The phase shift shifts everything right.
okay, yeah.
All right. And then if you had another 1, 2, 3, 4, you would similarly have something that looks like that. Okay. And then now what does all the other stuff do? The 2 stretches it, the negative flips it, and the plus 1 goes up 1. So you just got to be careful, how much can you comfortable doing in one time. Um, you can negate it first, that does that, goes the other direction. The 2 though pulls it up and pulls it down. It really kind of looks the same when you do that, but the plus 1 moves every point up 1, and that's where kind of running out of places to put this, but it still kind of has the same shape. It just shows that it's stretched up 1 like that. You may find, and we haven't talked a lot about this, you may find the table is better for tangents because there's only 3 points. There's the minus pi over 2, minus pi over 4, 0, and pi over 4, minus 1, 0, and 1. You may find it's easier to make a little table, especially for your final ordered pairs. I'm not sure if you guys are doing that, but that would be, a possibility here. Okay, let's do this. There's probably some questions you want answered that maybe you think are going to be on the test or something. Could you maybe look over your
Will we
problems
not
or
put apply the -2?
say that again? No, not as they're undefined. Like I guess some teachers show those as being in there, but they're undefined.
Okay.
And it's kind of it's nice because it's just, you don't have to include it. Same with pi over 2, it's undefined, but they're not actual points.
Okay.
Any questions that you see that you would like to have answered?
Um, just looking at it, I don't think so. Like it all makes sense, yeah.
Let's look at 20 then. Um, all right, so I want you to factor out the 2 and tell me what goes in parentheses here.
Um, x minus 3 pi over 4.
Like this.
Yeah.
Okay, very good. Okay. Um, so the period is pi over 2, and the phase shift is 3 pi over 4 right. Is that okay?
Yeah.
Just a moment here. Period. How do I explain this? All right. So normally with our cotangent, we start at 0 and we know to go out pi. All right. But our period is um sorry, our period is now sorry. Our period is pi over 2. So you actually do the period before the phase shift here.
Oh,
All right.
okay.
No, no, this isn't, I'm trying to graph this because I don't do this. I never do these by hand ever. Pi over 2. Yeah, okay. Sorry. I don't know why this, no, I'm wrong. You always got the phase shift. You always move the phase shift first and then add in the period. So um this 0 moves to 3 pi over 4. Okay. You always do the phase shift first. Then you add in the period. So you're going to add in pi over 2. So you have to do 3 pi over 4 plus pi over 2, which is 2 pi over 4, which is a big 5 pi over 4. So your next window here is 5 pi over 4. And that width has to be the period. So it is always the phase shift and then the period.
Yeah.
Okay, so that takes care of that. Now, the next thing is the parent function. So it's here, it's there, and it's this little snake, but you've got to get these points. You've got one here, it's pi. It's the midpoint between 3 pi over 4 and pi. So you're going up by pi over 8. So it's 7 pi over 8, comma 1. And then right after pi, before 5 pi over 4, is 9 pi over 8, comma negative 1. Is that okay?
Mhm.
All right. So we can do the other cotangent one. Actually, let's do 26 as the tangent one. We should do that one next. And if you had to go at another period, you just add to it and it looks the same. Okay, this one you have to factor out a 1/2 from both. Can you tell me what goes in parentheses here?
Um, 2 pi?
Okay. The period of this is pi over 1/2, which is 2 pi. The phase shift this time, though, this is bad here. It's 2 pi left. Okay. So you're moving everything 2 pi to the left. So that's where this gets like normally here it's minus pi over 2 to pi over 2. Okay, but you're moving it first 2 pi left, but then the period is 2 pi. So I don't know how much detail to go into. The let me do something real quick here. I'm gonna do this. The fact that these are the same kind of matters in graphing. They basically kind of cancel each other out. Um, because when you move something left, but then its period is every 2 pi, it's basically undoes each other because these things are periodic. I know that's not a great explanation, but that is kind of the reality here. So like this normally is the period, and so the period is 2 pi now, which means that this moves out to negative pi to pi. And then if you move everything left, like you say, okay, I'm going to move this one left. I guess I can't do it with the digital link. I move it left 2 pi. Well, because it's periodic, it's going to repeat and repeat. So there's certain situations where these sort of undo each other. I don't know how much of that you're going to have in this class, but that would be something to look for. So it ends up that this ends up being the same as just as the base one here. Now, when does this happen? The period and the phase shift have to be the same. That's the case when it works. When they're not the same, that's where you have to do the phase shift first and then the period. I would also recommend doing a table just to confirm your points.
Okay. Like calculate the points.
If you really are stuck, that's another way. It's always your backup plan. In reality is you're not going to ever be asked to graph these again, besides this course. If you take calculus, nobody cares. They just care that
Mm-hmm.
you know the shape of it. Um, they don't care that you can get this exactly.
Okay.
All right, we're going to stop there for today.